Cherry learn.
Hello, cherry learners. The ocean's saltiness has always been a curiosity, and it turns out the answer lies in a mix of chemistry and geology. The salt in seawater primarily comes from the minerals in rocks on land. When rain falls, it absorbs carbon dioxide from the air, creating a mild acid. This acidic rainwater breaks down rocks and minerals through a process called weathering. As rocks dissolve, they release various salts, including sodium and chloride, which are then carried by rivers and streams into the ocean. This process has been happening for millions of years, gradually increasing the ocean's salt content. Once in the ocean, salt doesn't simply wash away or disappear. When water evaporates from the ocean's surface to form clouds and eventually falls back as rain, it leaves the salt behind. This cycle means fresh water returns to the ocean through precipitation, while the salts accumulate, making the ocean saltier over time. On average, ocean water is about 3.5% salt by weight, though this concentration varies in places like the Dead Sea, which is far saltier, or the polar seas, where it's more diluted due to melting ice. If you could extract all the salt from the ocean, it would form a layer over 500 feet thick across the entire surface of the Earth's land area. Unlike the ocean, lakes and rivers don't taste salty because they are part of a continuous cycle that allows salts to be carried away. When rain falls, it weathers rocks and minerals, picking up small amounts of salts along the way. These salts flow with rivers and streams toward larger bodies of water like the ocean. Since rivers are always moving and eventually empty into the ocean, they don't have the chance to accumulate large amounts of salt in one place. In contrast, the ocean acts as a final sink for these salts. When river water reaches the ocean, it brings salts along, and over millions of years, these salts have built up in the ocean. Because water in the ocean evaporates and leaves the salts behind, they don't get carried away, making the ocean much saltier than rivers or lakes. Some lakes, like the Great Salt Lake in Utah or the Dead Sea, are exceptions because they have no outlets to drain into other water bodies. Instead, they rely only on evaporation, which leaves salt behind and results in high salinity. But for most lakes and rivers, the continuous flow prevents salts from accumulating, which is why they don't taste salty. So, next time you're at the beach and taste that salty water, remember it's the result of millions of years of minerals flowing into the ocean, a fascinating reminder of the Earth's complex and ongoing processes. Thank you.